Hello everyone, Prashant here. I'm going to teach you this simple experiment of conducting the linear convolution using circular convolution. This is one of the experiment in our MATLAB based digital signal processing lab. For this, I have considered simple two signals. Say signal one is 3, 4, 1, minus 3, and signal 2 I have considered as 1, 2, and minus 1. You can consider different signals and try working out the solutions and verify the answers using the software. Okay, so this S1 and S2 are these two signals. In the other experiments that you have conducted, you know how to conduct the circular organize or compute the circular convolution of the signal. Now, the challenge is that you have to use the linear convolution. Sorry, you have to compute the linear convolution using the circular convolution. Now, before we go into that, let's see what will be the circular convolution. You know, you can arrange the signals like this, circularly, shifting one step at a time, and then you can write one of the signal in this manner. The other signal can be written as one column matrix, and then you can multiply the two matrix, you will get the resultant. For example, I have written 3 4 1 minus 3 as 3 4 1 minus 3, then shifted by one step, again 3 4 1 minus 3, and so on. So I have written it three times shifted, and the other signal is actually having only three samples in it. So circular convolution, it will have the output which will be having a length of the maximum of the two. So one is having the length of 4, the other one is having length of 3. Therefore, the circular convolution will have an output which is equal to the length of 4. So to get that, we have to append 1 0. This is what you have done in the matrix method. So 4 and 3 are there. So out of this 4 and 3, the 4 is the maximum, and the length will be 4. What is the output? Output is minus 4, 13, 6, and minus 5. So this is how you get the circular convolution. But we want to obtain linear convolution. Method can be anything, but that circular convolution is to be used. Okay, so I have shown here appending 1 0. Now let's see further. I'm going to, so what is the length of the linear convolution? So linear convolution, you can quickly, you can perform this operation based on just writing it in terms of a table. So 3 4 1 minus 3 is written here. You have written 1 3 and minus 1, and then you have cross multiplied the values. That is 1 into 3 is 3, 1 into 4 is 4, 1 into 1 is 1, 1 into minus 3 is 3. So this way you have written for even 2 and minus 1, and then you have added these diagonal values, like, so this is 3, then this is 6 plus 4 10, then this is 8 minus 3 plus 1 is 6, and like that you can go on adding, and finally so you see uh, this is linear convolution. A linear convolution has a separate formula itself, so you can use that. This is just for verification, and this is sufficient to quickly get the result. So that's why I have written this particular table method. Whichever method you use, linear convolution will be it has to be this sequence only. Then question is, what is the length of this linear convolution and how do we get it? So length of the linear convolution is, as you can see, 6. That is 1 plus 2, then 3, 4, 5, and 6. 6 elements are there. So length of the linear convolution is 6. How do we determine this before we calculate? So you know from our basic discussions in signals and system class that it is L plus M minus 1. So length of one signal plus length of the other signal minus 1. One signal is having 4 samples, the other signal is having 3 samples. 4 plus 3 is 7, 7 minus 1 is 6. So this is how you can get. Now, as I told, this is linear convolution. Previously, the step and other things that were shown was this is circular convolution. So how are you going to obtain linear convolution itself, this result itself, using the circular convolution? So that is the question that we have to see, how to use circular convolution to get linear convolution. Now solution that has been given is like this. So you can append two zeros to S1 and then append three zeros to S2. Why? You can see here, if you append two zeros to S1, S1 is having a length of, you can see the signal. S1 is having a length of 4. So if you append two zeros, it will become 1 and 2. So the total length will be 1, 2, 3, 4, 5, and 6, because 2 0. And you append three zeros to this signal. So if you append 3 0, it will be 0 0 0. So it will be 3 and 3, that will be 6. So you are going to make the length of this signal as well as this signal equal to 6. Why 6? Because the length of linear convolution is going to be 6. So you should decide based on the two inward signals. So if one signal is 4 length, the other one is of 3 length, then you are going to append two zeros to this and three zeros to this. Assume that the two signals are, each of them are of length 3. If each of them are of length 3, then it will be 3 plus 3 minus 1. 3 plus 3 is 6. 6 minus 1 is 5. In that case, you are going to append two zeros to the first signal, two zeros to the second signal, so that they become equal to, their length becomes equal to 5, and 5 uh, and 5 signal can be put in circular convolution. The output will be 5. Okay, so that's the idea. So append two zeros to, in this example, we are going to append two zeros to the first signal, three zeros to the second signal, so that they attain the length of 6 in this example. Okay, it should not be a standard, it is not a standard. Okay, so as per our calculation, L plus M minus 1. Okay, and then that input signal that you have got by after appending zeros, that pre-processed signal, that can be input to the circular convolution. Then how do you calculate the actual process of circular convolution? That can be any method. Say for example, this matrix method. It can be the formula, direct formula can be used, or you can apply DFT to both the signals and then multiply their DFTs and get back in time domain applying inverse DFT. So that is also possible. So I'm showing you here the matrix method. So you can see here that first signal has been appended with the two zeros, and I am shifting that. And the second signal is appended with three zeros. So this matrix is of size 6 cross 6. This matrix is of size 6 cross 1. So 6 cross 6 multiplied by 6 cross 1 will give you 6 cross 1 matrix. So here it is two zeros appended, shift it, and again right shift, like that, you can get this matrix. So this matrix method, as I have explained in one of our previous labs, is possible to be done by these circular shift inbuilt function and concatenation. Okay, horizontal concatenation. So you can see we have appended sufficient number of zeros to each of them, such that each of them have become each 6 length signal, and you get the output. So this whole process is actually circular convolution. The output is also circular convolution only, but we have made some pre-processing with the signal, such that though this is linear circular convolution, the actual output that you have obtained is the linear convolution only. Therefore, by appending zeros to both the involved signals, we have, though used this circular convolution method, we actually have obtained the linear convolution. This is the concept. I want to show the output of such a method using our this MATLAB software. Okay, so here you can see I have already keyed in the whole program, and this program is there in the accompanying PDF file along with this video. You can download that and you can execute the program in your system. Okay, so this is performing linear convolution. This is this is our comments, and I'm clearing all the screen, and I'm clearing the command window and all the previous variables. Then I'm asking the user to enter the two sequences. So this is the sequence 1 and 2, and I'm obtaining the length of the two signals using the length inbuilt function. This is the inbuilt function length. I'm using the function to obtain length 1 and length 2. This is how now, as I had told you in previous discussion here, so what is the length of the this linear convolution? It is length of first signal plus length of second signal minus 1. Therefore, here I am going to find out the same thing, that is linear convolution length will be length of the first signal plus length of second signal minus 1. So to use this formula, I require length 1 and I require length 2. So I'm the line number 8 and 9 gives me this output, and I'm using that directly. I'm using it in the formula. Okay. Then, as I told you previously, I need to append zeros to each of the signals such that they become equal to the length becomes equal to the linear convolution. Okay, so here you see it's a very simple trick what is being done. So sequence 1 is sequence 1 itself, that is from here, and followed by some number of zeros. Now, what is the number of zeros that we are appending? You can see this is a simple trick that is being done. So zeros of 1 comma something. So what is this? This is length that is the length of the linear convolution minus length 1. So it is like for example, that previous example only, length of linear convolution is 6, length of the first signal is 4. So length of linear convolution minus length of signal should be 6 minus 4, that is 6 minus 4 is 2. So it is 2 value. So you are going to append 2 zeros to sequence 1. I'll remove this semicolons at both the signals, and I will execute so that you will be able to see the two involved signal. Purposely I'll put this some error some undefined variable, so that the program stops over there. Okay, so I hope that you have understood what we are actually doing. So I'll execute it. Enter the first sequence. What is the first sequence? 3 4 1 minus 3. This is my first sequence. Enter the second sequence. It is 1 2 minus 1, the same signal I had executed just a few minutes ago before recording this. So I'm showing you the same. Yeah, you look at this thing, what happened. So length of the first signal is 4, length of the second signal is 3, and linear convolution should be actually 4 plus 3 minus 1, that is 6. You see what happened? 2 zeros have been appended to sequence 1, and 3 zeros have been appended to sequence 2. So there is one error message also showing that there is some undefined function or variable er on line 17. Okay, this is purposely I have put, right? So I'll remove that. Okay, now let's look at what further we need. Now, if you remember the previous experiment on circular convolution, I am going to use the same code for this also. Reason is I'm giving you the two signals of which this circular convolution is to be done by the software. Yes. So I'm taking S1 as a transpose of the first signal, S2 as a transpose of the second signal, and then each of them is going to be circularly shifted for 1 to uh, length of linear convolution minus 1. So this is 6, 6 minus 1. So from 1 to 5, so many times it has to circularly shift and concatenate that shifted value with the S2. So you form a matrix, square matrix, which actually looks like this. So I'm going to show this matrix. um, yes, this matrix. So you are actually concatenating, you are shifting it and concatenating, shifting again, concatenating, shifting and appending, concatenating or joining end to end like that. That is then let us execute this again. So and this much is the whole concatenation, and this is the actual y means this is the variable in which I am multiplying the two, the same thing just now I have shown. This multiplication of the matrix, this 6 cross 6 matrix with the 6 cross 1 matrix is going to be this output. This output will be stored in this variable y. So let us put this error over here and then again execute. First signal, I'll take it as 3413. Then I'll enter the second signal, which is 1 2 minus 1. And yes, you can see. This is the second signal or the first signal, whichever that is having, it has been shifted, written, and I'm multiplying that with the first signal. Okay, so this is how the signal is, the two are multiplied, and you can see the result is 3 10 6 minus 5 minus 7 and 3. Okay, this output is sufficient. But if you want further, this display also, because I want to visualize the output. Okay, then I have to uh, plot the values. Okay, that plot is given the same thing I have used from the previous part. So this line number 36 to 50, so all these, there are three subplots. Each plot will have a title and a grid being shown, so that you are able to display the whole output over there. Okay, so I'm using, and by the way, I'm using the stem plot. Okay, stem plot is being used. So let's execute it once again. Finally, so you get this signal, first one, second signal as it is, and the output of linear convolution is shown on this figure window also. So this figure window is now using the subplot option, has been divided in 3 rows and 1 column. So 3 comma 3 comma 1 is here, 3 comma 3 3 comma 1 comma 1 is here, 3 comma 1 comma 2 is here, and 3 is over here. Okay, so this is how you get the circular. This is the program. I have explained the program step by step. I have explained this concept also. Anyways, concept is already known to you. This is how we obtain the circular linear convolution of two signals using the circular convolution. Okay, so in case of any doubts, you can always post the questions in WhatsApp group or individually also. Try downloading this and try to execute the same on your system. Okay, thank you, all the best.